Hello, everyone. How are you doing today? Great. I'm Sachin Kotwani. I'm the product manager for MLKit, and I'm accompanied by the great Isabella Chen, TL for MLKit. So before we get started talking about machine learning, I wanted to tell you about a hobby of mine. How many people here enjoy photography? Quite a few. How many of you have an SLR? So those of you who do know that photography is mainly about one thing, capturing light. And you do that in 3 different ways: aperture, shutter speed, and ISO. So aperture is how wide the shutter opens. And the wider it is, the more light it captures. But it also means only one subject is going to be in focus and the rest is going to be blurred. Shutter speed is how fast it opens and closes. So something that is fast shutter speed will catch a fast-moving object, but lets less light in. And then ISO emulates what in the old days film used to do. A high ISO number means that the light is really sensitive. The film is really sensitive, so it actually needs very little light, but the picture will be a little grainy. Now, imagine if you had to know all of that to take a picture. It would be overwhelming, right? Well, luckily, today you don't have to do that. You can just pull out your phone and it's auto mode. You just click a picture. You can even do it in portrait mode, and you don't have to worry about aperture or any of that. So we feel that machine learning today is in a similar stage as photography was in the early days. It can be overwhelming. There are a lot of concepts to learn: neural networks, forward propagation, backward propagation, gradient descent, learning rate, RNNs, CNNs, tensors. Let's look at what the workflow looks like for a typical machine learning developer today. First, they would have to, of course, find a problem that they want to solve using machine learning. Then they would have to gather data, massage it, split it. Then they have to find a model that they need to train, and you might want to tweak that. Then you take the data with the model, and then you train the model, you tune it, you evaluate it. You do that a bunch of times, and you need an ML expert or a data scientist to be able to do that. Once you're done with that step, you would give it to someone in DevOps and say, OK, here it is. The model works well. Please deploy it for me. And only then can a software developer start running predictions. What we want to do is we want to make machine learning just like the auto mode on your camera. We want to make it much simpler. So we want you to pick a problem that you want to solve or a model, and then we just want you to start using it. OK, so base APIs within MLKit allow you to do just that. While there are ML models under the hood, they're actually as easy to use as any other APIs. As you can see, all of the ones listed here are focused on vision, but there are more coming soon. If you do have some ML experience, or you would like to bring your own custom model, you can do that too. MLKit allows you to upload your own TensorFlow Lite model to the console, and then it serves it to your end users. What this means is that if you choose to, you don't have to bundle the model in your app, reducing the APK size. You can also run A/B experiments and do frequent rollouts without having to release a new version of the app into the console. So I'm going to start talking a little about image labeling. I forgot to mention face detection and face contours that we announced today. So that's another one of the features that just became available. But let me jump into image labeling, which is one of our APIs that I'll demo in a little bit. Image labeling API, like many of the other APIs in MLKit, is available both on device and in the cloud. On device, it's free. You can use it as much as you want. It's low latency. There's no network required, no network connectivity required, and it does about 400 or so labels. The cloud version of the API offers 1,000 free calls per month, and then it's paid after that. But it's higher accuracy classification, so it can do around 10,000 labels. So if you were to pass this image to the on-device API, you would get things like fun, infrastructure, neon. And if you pass it to the cloud-based API, you would see more specific things like Ferris wheel, amusement park, night, etc. So while we get our hands dirty here, I'm going to start implementing the image labeling API. What I did is I found an existing camera application in GitHub that I liked because you can process every frame. And I already set it up with a Firebase configuration and all the libraries, so I can just jump into the coding part. All right, so let's go to machine number 4. OK, don't see that on the screen. There we go. OK, great. So I found the onCreate method of the app, okay? And what I'm going to do is I'm going to do camera.add frame processor, new frame processor, and then I'm going to process each frame. So the first thing that I'm going to do, and I'm going to get an array of bytes that's going to come from the frame. So frame.getData. And now the bytes by themselves don't tell much, right? Because they're just a set of bytes. So I need to set up some image metadata. Metadata equals new Firebase image metadata dot builder. Okay. And now I'm going to tell it about the width. Did I do something wrong here? Image metadata. Oh, okay. That's better. So set width. And now I'm going to get the frame, get size, get width, and the same with the set height. Frame.getSize.get height. Okay. Set format. Firebase metadata. And here what I'm passing is the format of the image that my camera is giving me. I'm also going to set the rotation because I'm going to use the camera in rotation and in portrait mode. I'm going to set that to 90 degrees, and that's about it. And I'm going to do build. Okay. Next, I have to instantiate the image that I'm going to pass to the detector. So I'm going to say image at Firebase Vision image, and I'm going to then take the array of bytes together with the metadata, and that is that's the image that I'm going to be passing to the detector. So next I'm going to instantiate the detector, which is the part that does all the magic. So that's a label detector. Detector equals Firebase Vision dot get instance dot get vision label detector. Great. Now here's where the magic happens. You create a task with the detector, task with a K. I'm going to call it result equals detector dot detect an image, and I'm going to pass it the image, and then I'm going to add on success listener, and then that's a new on success listener, and inside this on success listener is where I'm going to extract the contents of what was detected. So I'm just going to, in order to save time, I'm just going to copy paste this snippet in here. And all that's doing is that it's taking the first 3 labels and it's going to assign them to a field that I have in my camera app here. So let me plug this in. All right, and can we have, okay, great. So the emulator started, which is not what I wanted. Although you can see it works with the emulator too if it's not showing on the screen. Okay, it's not. Let me switch. Shut down the emulator and try to run this one more time, this time on the phone. Okay. It's building. It's installing. As you can see here, okay, great. So here you go. So here is the, it's probably not detecting things right now. Let me see if I point it to the crowd. Oh, it says event, fun, which hopefully all of you are having. Chair, sitting, hand, nail, seeing some jeans there in the background. So as you can see, it's really easy to start implementing something using machine learning with MLKit. So let's switch back to the slides. Thank you very much. That was just a few lines of code, and you can do something very similar to what I did, but for text recognition, which is what I demonstrated. Face detection, barcode scanning, image labeling, and landmark recognition. All of them work in a very, very similar fashion. Here are some of our partners that have worked with us very early on and have implemented this functionality. So I encourage you to download their apps and check out what use cases they utilize MLKit for. Now, if you thought this was fun, wait till you see what Isabella has to show you. It doesn't have to be just the base APIs, right? If you want to go to more advanced use cases, you can create your own custom models, and Isabella is going to show you how to do that.
Thanks, Sachin. I'm Isabella Chen. I'm a tech lead of MLKit team. So are you excited of all the base APIs Sachin just introduced to you? Yay. Do you want to try it out yourself, right? So some of you might ask, like, what if I have my specific machine learning scenario? What if I have trained my own custom machine learning model? So today, in the next 10 minutes, I'm going to show you how, like, with your custom model, MLKit can help streamline your production workflow. Also, for those of you who are not too familiar with machine learning, I'm also going to introduce to you how you can train your own model. Now let's get started. So TensorFlow is an open source machine learning framework for everyone. And TensorFlow Lite is a lightweighted solution of TensorFlow, which is tailor-made for mobile devices. So once you have a custom model, the first step you want to do to make your pre-trained model to work better on mobile is to convert it to TensorFlow Lite. By doing the conversion, you can make your model smaller and runs faster on mobile devices. And secondly, I want to talk a little bit about Firebase MLKit's cloud model hosting. So one thing I myself really like about Firebase is it's enabling mobile developers to go serverless. You don't need to maintain your own servers, taking care of scalability, global availability. So with MLKit in the same spirit, you can just upload your trained TensorFlow Lite model to Firebase console, and MLKit will fully take care of model hosting, model downloading, and model updating for you. And thirdly, with the MLKit Cloud Model Serving feature, together with all those toolings offered by Firebase, doing A/B testing is really simple if you have multiple versions of your model. Now let's take a closer look. This is how MLKit's end-to-end stack looks like. At the top, you get the Android and iOS native SDKs with very similar API surface. And the underlying, it's powered by TensorFlow Lite, which can utilize neural network API on Android and Metal framework on iOS, benefiting from hardware acceleration and maximizing computational power of your users' mobile devices. And to get such a TensorFlow Lite model, it's really simple. TensorFlow Lite offers this TF-Lite convert script, as you see on the slide. By running this simple command, you can easily get back a TensorFlow Lite model suitable for running inference on your mobile devices. And once you have the TensorFlow Lite model, you can choose to upload to Firebase console. As we see here in MLKit Custom Model tab, so you can give your model a name, and then you're ready to go. In this case, I call my model Fish Classifier V1. And later, when I have V2 of my model, I can similarly upload it there and call it, for example, Fish Classifier V2. And once you have multiple versions of your model uploaded to Firebase console, I will show you how to do A/B testing. So first of all, you need to create an experiment for your model name via Firebase Remote Config. Then in the Remote Config SDK on both Android and iOS, you can easily get the model name. You specify the model name with Firebase Cloud Model Source and register your Cloud Model Source with Model Manager. From there on, you can leave everything to MLKit, who will fully taking care of downloading the model for you, updating the model for you. And then you can choose to report performance and your users' actions via Firebase Analytics. And lastly, you go to the Firebase console, and there you can compare the metrics of your different versions of models, how they perform side by side. A/B testing is just that simple. But some of you might say, okay, yeah, following these steps indeed seem to be very easy, right? But for me, the most difficult part is how can I train my model? When I was at Google I/O, there's many developers coming to me explaining the machine learning scenario they have in mind, but many of them simply didn't know how to get started. For example, we have a partner, FishBrain, who trained a model that can recognize different species of fish. You might think, okay, that's a cool idea, right? Like, can I similarly train my own model, which can recognize different species of birds? Or maybe you have a calorie tracking app and you want your app to be able to recognize different desserts. So today I'm going to show you that training an image classifier might not be as difficult as you once have thought. So first, I want to talk a little bit about the magic of transfer learning. So modern image classifier model could be very complex and having millions of parameters. Training them from scratch requiring huge amount of label training data as well as computational power. But transfer learning could help shortcut most of the training process by reusing models previously trained on related tasks. As you can see here for this particular example, we are reusing an existing image classifier model by Google, which is based on convolutional neural network. And the retrain script here will reuse all the lower layers of that existing model and simply retrain the last layer. All you need to do is preparing your specific training dataset with your specific labels, running this command, and you can easily get back a retrained model like specific for your usage scenario. So if you want to try it out, just search for Tensorflow for Poets. It's a collab provided by Google, which can guide you through the entire retrain process end to end in about 20 minutes or so. So I strongly recommend you check this out. And lastly, I'm very excited to tell you about the compression service offered by MLKit. So for the compression service, it can do pruning and quantization of your model. And it also performs join learning and distillation following a teacher-student training strategy. And using the compression service, it can help reduce your model size without too much loss in accuracy. For example, there's this FishBrain partner I mentioned to you earlier. When they first came to us, they had a model more than 80 megabytes large in size. But eventually, we managed to compress the model for them and give back them a model less than 1 megabytes, but without sacrificing accuracy. And to use this model compression service, you don't really need to share your entire model with Google. Just following our instructions and then come up with this one single TF record file and upload to Firebase console. After about 4 to 6 hours, you will be able to get back multiple versions of your smaller models with your chosen size. So for any of you interested in trying out this alpha compression service, just follow this link to sign up. Okay, now let's recap how custom model workflows look like. So you first either train or retrain to get your own model. And then you convert your model to TensorFlow Lite, either by using the TF Lite convert script I just showed you, or you can choose to use our compression service to do the compression and conversion of your model. Once you have the TensorFlow Lite model, you can choose to deploy it to Firebase. And finally, you use our Android and iOS SDK, which can help you download the model and run inferences. And then finally, it's demo time. So for my entire family, we enjoy traveling, experiencing different cultures in different countries. When my son was 3.5, we brought him to London. He quite enjoyed the trip in London, like taking the double-decker bus or cruising on River Thames. After we coming back US, whenever we see a UK flag on TV or on the street, my son would excitedly shout to me, "Mommy, look, London, UK." And later, we brought him to other trips to Germany, Austria, or Canada. And after coming back home, he could always learn how to recognize country flags of all those countries he have been to. So I'm always amazed how fast young kids can learn and do image recognition. So I was wondering if computer or even mobile devices could do the same thing. So I actually retrained to get this flags classifier following the same workflow I showed you earlier. I got some of the training data from Google image search, and with little help from my son and then my husband holding the flags for me, and I got some of other training data. So now let's take a look at demo. I'm going to unlock my computer. OK, here we go. So I built this very simple demo app. And let's first start with some pre-taken photos. This is a pretty well-taken photo of US flag in its flat position. So let's take a look. OK, the model is pretty confident this is a USA flag. And second, let's try a slightly folded Indian flag image. OK, the model correctly identified this is an Indian flag. Next. Actually, is it a little too boring, if we are just looking at these pre-taken photos? How about some live demo? But honestly, it's a little bit risky because I'm not sure whether my model will be a little bit nervous on stage facing the large audience. But anyway, let's give it a try. First, let's start with this UK flag, which my son could recognize. Anyone of you from UK? Oh, cool. OK, let's try if this model can recognize the UK flag. Let's take a look. OK, wow, it's 100% confident it's UK. Good job, right? OK, second, let's try Germany. Anyone from Germany? Whoa, yay, many Germany developers. OK, let's take a look. Germany, the model is also pretty confident it's a German flag. Last, let's do Sweden. Anyone from Sweden? Wow. Let's take a look. Yay, Sweden. Finally, let's invite Sachin back on the stage. Oh. Sachin is holding a Czech Republic flag. So we are really excited to come to this nice city and nice country to meet with all of you here. So let's take a look whether the model can recognize this Czech Republic flag. Let's take a look. Czech. I hope you enjoy our talk today and get some basic idea how you can train your model and use it with MLKit.
Was that cool or what? So whether you're just getting started with machine learning and want to use our base APIs, or you're dabbling into building your own models, we can't wait to see what you build using MLKit. And if you have any questions, we'll be waiting for you at the Ask Firebase launch. Thank you very much for listening.
Thank you.